Now let's say we have this triangle BST. So let's say this is a right triangle, and we have to identify the trigonometric ratios of one angle. Let's say this angle right here. So this theta. So before we can solve for the trigonometric ratios, of course, we need to have all of the sides. But as you notice, on this figure, side BT is missing. So we don't know yet the value of BT. But since this is a right triangle, so we can use the Pythagorean Theorem so that we can solve for the missing side. So using the Pythagorean Theorem, we know that BT squared plus TS squared is equal to BS squared. So let's substitute all of the values. BT squared plus TS is 4, then square it. BS is 8, then square it. So BT squared plus 16 equals 64. Then solve this. We have 48. Get the square root of both sides. So BT is equal to 4 square root of 3. So 48 is not a perfect square, but you can think of factor, which is 16 and 3. So that's why it becomes 4 square root of 3 cm. So let's write now here the value of BT, 4 square root of 3. Now that we already have the missing side, we can now solve for the trigonometric ratios of the given angle, which is the theta here. So let's write here sine of theta, or this is angle BST. So we have, so sine again is opposite over hypotenuse. So the opposite of this theta is the side BT. So we have 4 square root of 3 over the hypotenuse, which is 8. Again, if we can still simplify, then simplify it. So looking at the figures here, we can simplify this. So we have square root of 3 over 2. So next, let's solve for the cosine of the given theta. So it's now adjacent over hypotenuse. So the adjacent side is 4, hypotenuse is 8. So 4 over 8 can be simplified as 1/2. Next, let's have tangent theta. So the tangent of the theta is opposite over adjacent. So it's 4 square root of 3 over 4. So you can still simplify this, cancel out 4. So we have square root of 3. Now for the remaining 3 trigonometric ratios, we can just get the opposite of the first 3. So for the cosecant of the theta, we know it's the opposite of sine. So if the sine is square root of 3 over 2, then the cosecant should be 2 over square root of 3. But as you noticed here, there is now a radical sign on the denominator, and we don't want a radical sign there. So we have to rationalize this given so that we can simplify. So in order to rationalize, since the denominator is square root of 3, so we have to multiply square root of 3 on both the numerator and the denominator. So this will become 2 square root of 3 over, then square root of 3 times square root of 3. So this is just equal to square root of 9, or 2 square root of 3 over 3. So this is now your cosecant. So we will do the same thing for the remaining ratios. So let's have the secant of theta. So it's the opposite of the cosine. So if the cosine is 1/2, our cosecant will be equal to 2. Again, it's just the inverse. And last is we have cotangent of theta. So if the tangent is square root of 3, then the inverse of that will be 1 over square root of 3. So same case with our cosecant, there is again a radical sign on the denominator, so we have to rationalize again. So it's square root of 3 over square root of 3, multiply it on the 1 over square root of 3. So we have square root of 3 over square root of 9, or this is square root of 3 over 3. So that's it. We now have the values of the trigonometric ratios of the given triangle. Okay, for our last example, let's say we have this given, which is sine of the theta is equal to 5 over 7. Then we have to find the following. First, what we know is just the sine of the theta, which is 5 over 7. We don't know the triangle, we don't know other sides, just this one. So we have to use this in order to identify the missing side. So let's draw a triangle. So just draw a right triangle. Suppose this is a right triangle. There you go. Let's label this as ABC. And then let's set angle B as the theta. So we know for sine, it can be solved by dividing the opposite side by the hypotenuse. So that means the values given here, 5 and 7, are the opposite side and the hypotenuse of the given triangle, respectively. So this is our angle, or this is the theta. Let's locate the opposite side of this, and that is AC. Then this should be equal to 5. And then for the hypotenuse, which is AB, this should be 7. So that when you solve for the sine of theta, so it's the opposite over hypotenuse. So it's 5 over 7. Now that we have the two sides here, we need to identify CB, which is the remaining side. So let's use the Pythagorean Theorem here again. So it's AC squared plus CB squared equals AB squared. So AC is 5 squared plus CB squared. We don't know that. And then we have here 7 squared. So this is 25 plus CB squared equals 49. Then just simplify it more. 49 minus 25. So CB squared is equal to 24. Then just get the square root of both sides. So we have CB equals, now 24 is not a perfect square, but we can think of a perfect square that is a factor of 24, and that is 4. So 4 times 6. So we have 2 square root of 6. So this is now our CB. So let's write here 2 square root of 6. Now let's find the cosine of the given theta. So cosine of theta, cosine can be solved by dividing adjacent side by the hypotenuse. So that is, adjacent is this one. So that is 2 square root of 6 divided by the hypotenuse, which is 7. Now look if we can still simplify. If not, then that's it. That's the answer already. So we have 2 square root of 6 over 7 for the cosine of theta. Next, let's solve for the tangent of alpha. Now, this one now, alpha right here, refers now to a different angle. So if this angle is theta, now the other acute angle now can be labeled as the alpha. So that means they are now two different angles. So let's now solve for the tangent of alpha. So we will now be looking at this angle right here. Tangent can be solved by dividing the opposite side by the adjacent side. So looking at alpha, its opposite side now is 2 square root of 6. So that will be 2 square root of 6 divided by the adjacent side. So the adjacent side of alpha now is 5. So let's write here 5. So again, look if you can still simplify. If not, then that is the final answer already. Last, solve for the cosecant of the theta. So let's go back to this angle B right here, and then let's solve for the cosecant. So cosecant can be solved by dividing the hypotenuse by the opposite side. So the hypotenuse of this given triangle is 7, then divided by the opposite side. So the opposite side of the alpha is, we have 5. So it's 7 over 5. So that's it for today. I hope you learned something about trigonometric ratios and how to use them to solve for the specific values. And see you next time.